Project RISE is an effort to provide 2D and 3D mapping autonomously. Imagine if you're a first responder and you're responding to an incident inside of a building. You have no situational awareness. Imagine how much safer it would be for both you and for the people that you're responding to if you had access to 2D and 3D floor plans and models so that you could better plan the mission ahead of time. By current technology, if you want to create this type of imagery, you either have to do so by hand, which involves a tape measure, or you can purchase a device that you have to push around the building and it will scan it in 3D for you. However, these devices typically cost hundreds of thousands of dollars and are difficult to operate. Our sponsor, the SMAP Center, realized this problem, and we have collaborated with them to create Project RISE. Our product will allow our customers to frequently keep their building models up to date at an affordable cost.
So we sought to conform to the handicap accessibility standards of buildings, which allows us to fit through standard width doorways and hallways. We implemented our rover with a zero-turn radius, which provides high maneuverability. We utilize a 2D LiDAR scanner, and we're spinning it such that the 2D plane rotation generates a 3D mesh. From the 3D mesh, we are extracting a 2D floor plan for pathfinding. The LiDAR system that we're using generates a 30-meter scan radius, which is about 200 feet. So we're able to scan large rooms. We chose this implementation method for cost reduction. Our prototype is just over $7,000, and we believe that we can mass produce this for just around $6,000. Here we can see the rover traversing down a hallway, and as it passes each doorway, it is scanning into each office space. And you can see the distinct boundaries of the hallway and each scan extending into the office.
So for this project, we developed a accurate simulation which mimicked the output and the limitations of the actual hardware. And since we're integrating the LiDAR and 2 IMUs, we have to ensure that all the data coming in is coordinated, so we assign a timestamp to each packet for this purpose. And the LiDAR itself gives us distance data, and the IMU gives us the orientation of the LiDAR. And from there, we can do just a coordinate transformation, and we can reconstruct a 3D point cloud from this data, interpolating between the data points using a spherical interpolation algorithm called SLURP. The software also utilizes plane detection, so that we can reconstruct a 2D floor plan from our 3D mesh. And for the autonomy, we have a self-classification algorithm we developed, which divides the point cloud into a two-dimensional grid from which we can determine the optimal path for the rover to follow.